Redmond High School Pre-Calculus presents Jethro's foray into the Arctic regions of polar coordinates. The goal is to explore the subject of polar coordinates and how to convert them to and from rectangular coordinates. Hello, we're here in the North Pole with Jethro, a lonely polar bear. So Jethro, I hear you're searching for a magical rainbow. Where could it be?
Well, I know exactly where it is, but that's the problem. You see, it's at -2, 2 square root of 3 on this rectangular map of the North Pole. But since I'm a polar bear, I can only think in polar coordinates. Polar coordinates are made up of 2 parts. The first part is the length of the line from the origin to the point, and the second is the angle of the line. Too bad this is in rectangular coordinates.
Greetings from the South Pole. At the other pole, we've learned how to convert from rectangular to polar coordinates. Here we have a rectangular map of the North Pole. There's your wonderful rainbow. And that's us at the origin, the North Pole. However, we need to find out its location in polar coordinates. First, we need to find r. We can do this with the Pythagorean theorem. Since the sides of the right triangle are 2 and 2 times the square root of 3, we can write it out. 2 squared plus 2 times the square root of 3 squared equals r squared. Using basic math, you should know, Jethro, that we can find r to be equal to 4.
But polar coordinates have 2 parts, Gregory.
I'm getting to that. The second part is the theta value of the angle. We can find this by the relationship of y to x using arctangent. Arctangent of -2 times the square root of 3 divided by 2, -2 times the square root of 3 divided by 2 equals, -pi/3 radians. This is our theta value in the coordinate.
That's great, Greg. Too bad my Inuit friends can't convert from polar to rectangular coordinates.
Elementary, my dear Jethro. We just plug whatever angle we have into cosine and sine. Because y and x are equal to r times the sine of theta. Y and x are equal to r times the sine of theta, and r times the cosine of theta. We simply plug -pi/3 radians into these definitions. Y equals 4 times the sine of -pi/3. And x equals 4 times the cosine of -pi/3. And so y will equal 2 times the square root of 3, and x equals -2. So there's your rectangular coordinates back, Jethro.
Thanks, Gregory. Time to go find that rainbow. Wait! We're going the wrong way! See? We're going to the 4th quadrant, but the rainbow's in the 2nd quadrant.
Oh, yes, Jethro, I forgot. Polar coordinates can be expressed in 4 different ways. We're going at -pi/3 radians for 4 miles. However, we're going the completely opposite direction. That's because our angle is off by a whole pi radians. Since we're going the opposite angle, we should go the negative distance. In other words, we should go to -4, -pi/3.
What about the other versions?
Well, -pi/3 radians is the same as 2pi/3, -4pi/3, and 5pi/3 radians. Depending on which quadrant it's facing, we'll have to change our distance accordingly. So we'll be going 4 miles backwards if we're heading for -pi/3 or 5pi/3 radians. But we'll be going 4 miles forward for -pi/3 and 2pi/3 radians, since the rainbow is in quadrant 2.
You're a lifesaver, Gregory. Now let's find that rainbow for real.
Join us next time when we try to find where all the icebergs have gone.